So now we're going to graph polynomial functions and visually be able to look and see where those zeros are. And we've actually been doing this all along. So we're going to go back for a second to a line, right? Do you recognize that number one is a line? And I did these all y equals, even though they're functions and could have been f of x equals, right? I just did y equals, kind of make it a little easier on us. So we know the y-intercept is -1, the slope is up 2 over 1, right? Where's the root of that equation? Right, the root is also known as the x-intercept, right? It's where the graph crosses the x-axis. Do you remember how we found the x-intercept? Right, we let y equal 0 because every point on the x-axis has a y-coordinate of 0. So the root is 1/2. Now technically it's the ordered pair 1/2 comma 0, but we say 1/2 because it's understood that the root has a y-coordinate of 0. What if it's y equals x squared minus 1? What kind of graph is that? Right, it's quadratic, right? It's a parabola shifted down 1. Quadratic equations have 2 roots. What are the 2 roots of this quadratic? Right, 1 and -1. And we can solve that by hand, again, by replacing y with 0. I'm going to add 1 and square root both sides, making sure I do plus or minus. So now another quadratic here. Now this one, do I really know how it's shifted? I mean, actually I could like change the form, right, and find the vertex and all of that. But really, I'm just concerned here with the roots. So I'm just going to factor that real quick and say the roots are 3 and -2. So 1, 2, 3, and -2. Could I go to my graphing calculator and find the vertex? I could. Now I'm going to go back through and do what we call the end behavior. So this all right here is called the end behavior. It's how the graph behaves at the end. So it's saying as the x coordinates get bigger and bigger and bigger, what happens to the y coordinates? Are they getting bigger or smaller? Well, it's going up, so they're getting bigger, so they're going towards infinity. Where on the other side, as the x coordinates get smaller and smaller and smaller, what happens to the y coordinates? Right, they get smaller and smaller and smaller, also known as negative infinity. What happens at the ends of this quadratic? As x gets bigger and bigger and bigger, the y coordinates are also getting bigger. And on the other side, even when the x's get smaller, the y coordinates get bigger. So essentially, anything that's going up in the up direction is infinity, and anything is ending in any down direction is negative infinity. So here we see the up direction on both sides, so it's infinity, infinity. That's not going to be on the quiz or the test, but it's a good intro for, kind of officially learning it later on, and it's a big deal in pre-calc, end behavior. Sliding up to number 4, here it's factored for me. So this could have been written x squared minus 2x plus 1, but since it's already factored, I see it has a double root at 1. So we're going to learn here in a minute that double roots kind of bounce. They just touch that x-axis one time, and the end behavior is infinity, infinity. Now we're getting real here. So in here, I don't know how number 5 looks unless I graph it on my calculator. So I'm going to go to my calculator, y equals, type that baby in, and then look at what the graph looks like, which is going to be like this. I see that it only crosses the x-axis one time. It still has a power of 3. It's going to have 3 roots. One root is right here, and I'll show you how to find it on the calculator. And then what we've got is a pair of imaginary roots that are represented there. How do we find the real root? We're going to go on the calculator, and you're going to do, after the graph is on, second calc 0, and then you have to do this left-right thing where left is below the x-axis, right is above the x-axis. You hit enter to guess, and then it will tell you the 0, and the x-coordinate of that 0 is -0.15. And then it has 2 imaginary roots after that. You do have to know how to do that for the test. So second calc 0 left, right, enter, but we will, go over that also in class. How's our end behavior here? As x gets big, y gets big. As x gets small, y gets small. Another one here. Now this is nice because it's been factored for me, so I can see that the roots are 3 and -2 and -2. Again, I notice that double root there. And if I graph this on my calculator, which is what we want to do, graph it on our calculator, you'll see this bouncing here at the root of -2. The end behavior is just like the previous problem where it ends up and kind of starts on the other end going down. So now you're starting to see what those triple power graphs really look like. Here is a unique one because it's got a triple root at 1, a triple root at 1. If you graph this on your calculator, you're going to see this kind of thing, where this triple root, the graph actually goes through at that triple root, and again, infinity, -infinity. So we're really getting into like, how does a graph behave depending on the number of times the root repeats. So here I see a double root at -2, a triple root at 1. And again, only on your calculator are you really going to be able to see that graph, right? Again, it's got this classic behavior, and you see the bounce here and the going through there. Last one has a triple root at 3, quadruple root at -1. You might be catching on to the pattern here. This is going to be a bounce, and the triple root is going to be a through. So if you go back and look, like which roots bounced, which roots go through. Have you figured it out? Which roots bounce, which roots go through? The rule is if a root repeats, it's about the number of times the root repeats, not if the root itself is even or odd, but if it repeats an even number of times, the graph bounces. If it repeats an even number of times, the graph bounces. If a root repeats an odd number of times, what happens? If a root repeats an odd number of times, it goes through, meaning it goes through the x-axis. Or my catchphrase is, that's odd. Oops. That's odd. Let's see if it'll let me read it. That's odd. It goes through. That's odd. It goes through. It even bounces. I gotta squeeze it in there. That's odd. It goes through. It even bounces. Meaning if the root repeats an odd time, it goes through. If it repeats an even number of times, it bounces. There's a little chart here. I'm not going to go through the whole thing. I know it's really tiny. You're going to see on the homework that chart repeated, and that's just kind of giving you some overall guidelines of the shapes of graphs, if they're odd powers, if they're even powers, if they start positive, if they start negative. But we kind of want you to do those graphs and start to pick up on those patterns. So your graphing calculator is your best friend for graphing polynomial functions and finding zeros.